Next on the list of mechanism steps are rearrangements. And we have a couple that we're going to look at here. We have the 1,2 Hydride Shift and the 1,2 Methyl Shift. And these are very similar to each other, except in what is moving around. So in the first case, we're going to move a hydrogen, and in the second case, we're going to move an entire methyl group. And it's a little bit easier to move a hydrogen around, but under the right circumstances, methyl groups can move as well. So we have hydrogen here, and we have a positive charge. Now, this positive charge is located on a carbon that is secondary, and we have a tertiary carbon right next to it. And it's a little bit more stable if we have 3 carbons around a positive charge rather than just 2. So we could have a hydride shift. So what happens is the electrons from this hydrogen shift over to that carbon, and that hydrogen then shifts over and is now bonded to this carbon. And the positive charge moves over to this one. So what we'll end up with is this. We've got a positive charge on this tertiary carbon. So this is a lot more stable now because this carbon here. Now, this would be very well promoted if instead of this being a carbon, that was a hydrogen. Then this would be a primary carbocation, and that is definitely going to undergo some rearrangements. Now, similar to 1,2 hydride shift, we could have a 1,2 methyl shift, and it's so named because it's moving from one carbon to the next, so it's 1,2. So let's draw the same thing, except we have a methyl group up here. We're going to have similar results, actually. So we have hydrogen here, got our CH3 right there, and we start off, we have a positive charge here. Now, in this case, all of these over here are methyl groups. We'll emphasize that a little bit here. Now, what can happen is this whole methyl group just shifts over. So we have that, and the electrons from here are going to move over to that carbon. That will leave a positive charge here. So it's not really the positive charge moving. It's more, think of it more like, here's these electrons, they're moving over towards that positive charge. And we're going to be able to stabilize that a little bit more because this will be on a tertiary carbon instead of a secondary one. So now we'll have this. So in this case, we started off, we have 1, 2, 3, 4 carbon there. 1, 2. Well, we've actually changed the skeleton of the reaction. And if you've ever wondered why one site is reacting differently, where you would think, oh, the mechanism predicts that there's a positive charge going to be here at one point. Keep in mind that we could have a rearrangement, and you'd think that the coordination would happen here, but instead you notice the chlorine or whatever is the negative charge that's going to be associated with it ends up on this other carbon. Why is that? Well, we could have undergone a rearrangement. So just keep in mind, rearrangements do happen, and they can happen quite easily or quite readily when we have carbocations, especially when there's a place where the carbocation could receive greater stability, such as this tertiary carbon right here. So that is rearrangement, and that can happen when we have an area where the positive charge can be stabilized a little bit more.